So then we kind of went for the home run experiment, which is actually trying to get a sample that originated on the ISS.
And the goal was really to show that you could go all the way from a sample to an answer all on board.
I am going to do this really neat experiment today. Last week we took some surface samples, microbial surface samples. There'll be enough DNA after we magnify it to sequence it, and then from that sequence then we can determine what type of bacteria it is. So it's going to be really exciting for us, I think, to try and do this for the first time all on board the space station.
In that moment, she's in this microgravity science glove box as she's collecting those cells. My heart was just pounding because what she did had never been done.
Our DNA cake is in the PCR oven. We'll look forward to getting lots and lots of DNA from each of those 3 little bacteria colonies.
They're like, we can just patch your cell phone in to the space to ground loops and you can just talk to Peggy on your cell phone to do this. There's a hurricane raging literally outside, but the folks in Marshall, they're on it. They're gonna make this happen. Science on station is not stopping because of Hurricane Harvey. And right away, we saw one microorganism pop up and then a second one. I thought, oh my gosh, I am watching the first sequences ever of an unknown from space.
I checked several times. Like I ran a biochemical test and then I ran 2 different sequencing tests. We are 100% sure that our samples that we got back on the ground are exactly the same that we got on orbit. We did it, everything worked perfectly.
As a microbiologist, my goal is really that when we go and we move beyond ISS and we're headed towards Mars or the moon or wherever we're headed to, we have a process that the crew can have that great understanding of the environment based on molecular technology.
Subscribe for more space.